Okay, so thank you everyone for coming along for the final session of the Cross Society Python course. So hopefully you've been along to a few of the sessions now. We've covered a lot of different stuff at this point in the course. And this last week is going to be looking at something a little bit different. We're going to be kind of focusing on a use case that you might be wanting to use Python for, specifically data processing. It's kind of funny that AI has ended up doing this week because data processing is one of those aspects of programming that is often kind of tied in with AI and machine learning. And we're going to be looking at that a little bit today, not in a massive detail in terms of the AI, but because data processing is one of those jobs that Python is very powerful for. And it's also often a use case that we see Python being used for at university. So for example, in subjects like physics or in chemistry or biology, students are often tasked to take a data set, you have to pick it apart, analyze it, and these are some of the techniques that you can use to do that, to make that process a lot more streamlined and hopefully make it a lot easier to generate results from your data. So the first thing we're going to look at are data frames. So I think last week you covered libraries and what those are used for. So just a quick recap, a library is kind of an encapsulated bit of functionality. So it allows us to kind of extend what we're able to do with Python by providing extra code, extra kind of functions behind the scenes that will allow Python to kind of use those and do more with what we've got. So a data frame is kind of a method of storing data. So the first thing we're going to do is import a library called pandas, and pandas contains the definition of a data frame that Python's going to be able to use. So what we're going to have a look at is kind of how do data frames work. So data frames are kind of ways of storing various columns of data. So in this first example, we've got 3 rows here, and they're just simple arrays, each of them 3, or array or a list, each of them are 3 elements long. So we've got 197, 354, and 682. And what we're going to do is we're going to take these rows and we're going to create a data frame from them by passing in each row and then giving it an index. And the index is going to be kind of a label for the row. So the first row is going to be row A, the second row is going to be row B, and the last row is going to be row C. So if we go ahead and run this, we can see we get the same outputs before. So you can see here, this is kind of what our data frame structure looks like. So we've got each row, A, B, and C, with the data as we've kind of defined it above. And also each column has been given a heading. Now, because we haven't specified any column names, it's just gone for 0, 1, 2, so kind of standard Python indexing. But we'll see later on that we're able to kind of change what this is. So we have a data frame, but how do we get the data within it? So when we have a data frame, we can access the data using indexing, kind of similar to how we did with a list. So we can get the first column of the data frame by calling df or data frame. So df is our data frame object, and then with those index brackets, the square brackets, we're going to put in 1, and that will tell it the first column. So it's the column name. So you see when we run this, we get 958, and that is the first column in our data frame. Now, suppose we wanted to get instead the first row of data. Now, this is a bit different. Because data frames have columns and rows, you can't use kind of the same indexing method to get a column or a row, because otherwise it might get confused. It doesn't know if you want the column or the row. So we're going to use the .loc function or .locate, and this indicates we want to index using the row label. So when we pass in the A label, it's going to take row A, which is outputted as this kind of list, as 197, which we can see corresponds to the row up here. We can also index a row by the position of the row using iloc. And this will, instead of using the labels, it will use the position. And in this example, we'll get the second row, and we have to pass in the argument 1 because, similar to lists, the indexing starts at 0. So 0 is that row A, 1 is row B, and 2 is row C. And you can see here that we've got the correct row. Now, a really cool thing with data frames is, unlike traditional indexing, you can perform some kind of more intelligent selections. So here's an interesting example where we're going to tell Python, we're going to get our data frame, and we want every entry that's greater than or equal to 5. And when we run this, Python is going to give us back another data frame, but this time it just contains false or true whether an entry meets our criteria. So you can see we've got true, 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 true in this kind of upside down L shape, and those correspond to the entries in the original table, where all these entries are greater than 5 and all these ones are less than 5. So we're getting kind of the output that we might expect. Now what we can do beyond this is we can take that data frame that we just created and we can pass it as an index to the data frame itself. See, so to kind of explain this bit of code, we're taking the data frame and we're passing it those kind of true and false values, saying where we want to get the data where it's greater than 5. So when we pass this in, you can see that where the data is greater than 5, it returns the data. But where it's not greater than 5, it just returns nan, and this kind of is equivalent to just saying data didn't match the criteria, like not available. We'll kind of cover that a little bit more later on. And the other thing we can do is we can sometimes, if we wanted to change the row indexing, we can change it to something else, kind of using this functionality here. So we can specify a new index as a list. So instead of ABC, we want to change it to XYZ. And we can call the index kind of using the same indexing notation. So we can say data frame, we want to take that index and we want to change it to the new index. And then we'll just call setIndex as this column here. So yeah, so kind of what this is doing behind the scenes actually is this line here creates a new column in the data frame with our index data, and then we tell the data frame we want to set that column as the index. So that's why it's now labeled index, and you can see it's X, Y, and Z instead of ABC. So that kind of covers the basics of what a data frame is. Now for the rest of this kind of session, I think a really good way of learning about data processing is to kind of see it happen. So we're going to work through an example of a problem where you might want to use some data processing, and we'll kind of see how Python allows us to make a lot of this process quite easy, quite simple. So we're going to look at a data set that contains data about customers using an e-commerce platform, so like an online shopping platform. We're going to import this data set into Python, kind of like we did in week 4 with reading and writing files. We're going to clean it up a bit. We're going to apply some processing to the data set, so it'll be easier to work with. We're going to visualize the data set. We're going to generate some graphs. We're going to analyze some of the trends. And then at the very end, we're going to predict the values of new data points based on the existing ones. We're going to kind of create a little bit of a machine learning model, just as a kind of bonus at the end. And this should hopefully kind of mimic the process you'd want to go through if you were doing a data processing project in your own work. And hopefully give you some ideas of the techniques that you might want to be aware of, you might want to use during that. So the first thing we need to do is we need to import our data. So you can see down the side here, I've got this e-commerce customers CSV file. And this contains a whole load of data, I think it's about 500 rows or so, various different data about various different customers using this platform. So the first thing we're going to do is we're going to read this in. And Pandas is really nice. It can take a CSV and it can automatically pull that into a data frame. So we don't have to read the CSV and manually put it into a data frame. We can just use this read CSV function and it's going to take it straight in as a data frame. So we'll go ahead and run this. And then the next method I'm calling the .head is just going to return, it's going to print out the top of the data frame. This is really helpful for visualizing, just making sure that something has worked as you expect. You can just call dataframe.head or e-commerce data.head in this instance, and it's going to print out the top 5-10 rows of the data frame just so we can see what's going on. So let's just have a quick look at this data before we kind of dive in further. You can see the first column is an email address of the user. The second column is their address. Then we've got their avatar on the site. And then kind of some more numerical, potentially more useful data points. We've got the average session length they spend on this platform. We've got the time they spent on the app, the time they spend on the website, the length of their membership to the platform, and then the yearly amount they spend. And we can imagine this scenario if we were this company who run this platform and we want to kind of look at this data, we'd probably be concerned about that yearly amount spent. We're looking to understand what affects that, potentially how can we increase that, where might we want to prioritize our company's efforts in order to make that more valuable for us. Just a small aside, if you're working with a data frame saved in an Excel spreadsheet, you can use the read Excel function to achieve the same effect. Note for this, you'll also have to specify the sheet name. So obviously Excel workbooks have different sheets in them. So you'll just have to say which sheet you want to grab So as an example, I've got an Excel data file here. I won't bother opening it up, but we can also read that into into pandas, into the data frame, and that example is available on the Google Drive. So if you want to have a play around with that as well, you're more than welcome to once this kind of lecture style bit is over. So once we've got our data imported, one of the first things you usually have to do is clean the data. It's sometimes quite unlikely that you'll have a data set that's kind of perfect, ready to work with. Sometimes you might have issues like missing values of information that might make rows kind of difficult to understand or process if they're kind of missing one of the values. It might make things fall apart later on. So a couple of things we can do first is we can describe the data. This is a really handy way of understanding what the data looks like in your data frame. So I'll go ahead and run this. I'll kind of explain what this output is doing. So it's going to take all the numerical columns, so kind of those like time on app, time on website, stuff like that, and it's going to give us the count, so how many data points there are in each one. It's going to tell us the mean and the standard deviation, and the minimum and the maximum value, and also the different percentiles, so the 25th percentile, 50% percentile, and 75th percentile. Now, these might be a bit overkill for what you're trying to do, but it's definitely very helpful to at least see a mean and standard deviation to kind of understand what's the distribution of our data looking like. Just so then we're aware of how we're kind of processing and dealing with these values. It gives us a bit more information to work with, and quite easily as well. With just calling one function, we don't have to go ahead and compute a mean for each column. We can just call this one function. It'll give us all that information pretty much for free. And we can also use the .info function to understand the data type for each column, and it also can give us information about any missing data. So I'm going to go ahead and run that. And you can see that it's telling us that we've got 500 entries, but for each column, it's only about 495 or 496 non-null. So null indicates that there's missing data. So we can see that for each column, there's about 4 or 5 values that are missing, that haven't got the data in them. So this is where we might want to start doing some data cleaning. We might want to get rid of those rows because they might mess up some of the stuff we're doing later on. Now, fortunately, Pandas has really a lot of functionality designed to kind of deal with all these different problems you might come across. In this case, we're going to use the drop na function, and this is just going to take any values that are null or nan, and it's just going to get rid of them. So effectively, if a row contains a value that's missing, we're just going to kind of remove that row from our data set. Now, in the real world, you might want to do something a bit more clever. You might want to say, OK, if it's a numerical value, why don't we just replace it with the mean instead of removing that row? But in this case, for lack of time and also just to keep things simple, we're just going to remove any rows that contain any missing data. So once we've done this, the data frame should be kind of complete. There shouldn't be any gaps in it. So we've done that. We use the inplace equals true argument, which will tell Pandas to update the data frame itself. Otherwise, it will kind of generate a new version of the data frame with the missing rows. It won't actually update the data frame itself. And that inplace equals true argument is quite common in a lot of Panda data frame functions. So sometimes if you're in a processing job or whatever, you've run this function and it hasn't seemed to work. It might be that you haven't specified inplace equals true. So it won't have actually overwritten the data frame. It'll have generated a new one instead. So we can go ahead and run info again. And you can see it's removed a lot of those entries. We've now only got 462. The reason why it's changed in that way is because the missing entries weren't all in the same row. They might have been one row might have been missing the email, and another row might have been missing, I don't know, the time spent on the website and the time spent on the app. So because they're kind of randomly assorted, removing those will kind of give us a bit more of a random size of data. So 462, that's where that number's coming from. So we haven't removed more than we needed to. And we can print out the head of the data frame, and we can kind of see it looks fairly similar. So that's all good. We know that we've kind of still got the full rows there. Clearly, we've removed some of the ones that have missing data. So that's no longer going to be a problem. So the next step we want to look at then is data processing. We've cleaned our data up. We've made it nice to play with. And now we're actually going to play with it. So putting ourselves back in that context of this company, wanting to understand, how are we going to make our platform more successful, the first thing we might notice is chances are the email and the avatar aren't going to affect the yearly amount spent, because those are kind of, email should be unique to each row, so there's not going to be any trends we can really analyze there. And we wouldn't expect the person's kind of avatar, at this stage it's just a color on the website really. We don't think that's going to have a massive impact on how much money they're going to spend on our platform. So what we're going to do is we're just going to go ahead and drop those columns. And dropping just basically means we're going to get rid of them from the data frame we're working with. So we call the drop function with the email and the avatar kind of heading specified. Axis equals 1 is telling it the axis to work on. So if you imagine the data frame is kind of like a table, axis equals 0 is going to be going along the rows, axis equals 1 is going along the columns. So axis equals 1 just telling it look at the columns and not the rows. And then in place equals true. Again, this is telling it we want to modify the actual data frame. We don't want to generate a copy. Obviously, if you did want to kind of keep both, then you'd remove the in place equals true and do something like e-commerce 2 and set it equal to that and remove the in place equals true. And that will then allow you to keep both. But in this instance, we're pretty sure that we don't want those columns, so we're going to get rid of them. And again, if we call get the head of the data frame, you can see that we've removed this email and this avatar column from before. They're gone now. We've just got the address and all those numerical values that we want to look at. So the next thing we might want to process is address. Now, currently, it shows each user's kind of exact address, which is very, very specific. And again, you probably wouldn't be able to analyze any significant trends in the data based on that. However, we could try and process this down to just a state. So this data set comes from an American data set. So all the addresses have at the end some sort of state they're from. So in this case, it would be Ohio. And potentially, that might allow us to see, potentially there's like one state that has a lot more spending than the other states. There might be some interesting trends there that we can explore. Now, to kind of process data, we're going to use an apply function, which is a really cool thing that data frames can do, where they'll be able to take kind of a custom bit of code that you've written and apply it to the values in the data frame. So the first thing we need to do is we need to define a function that's going to allow us to do this processing. Now, if we look at the addresses here, you can see that all of them start with, house number, whatever, street, city, then they have the state, and then they have the zip code. And the state is always state and then zip code and then ends, and they're always separated by a space. So because we know this in the data, we can kind of exploit that fact to process the address and just get that state. So we take in an address, and we're going to say, OK, we're going to split this by the spaces. So this will give us a list of all the kind of components in the address. So the first one, in this case, it would be 1414. Then the next item in the list would be David. Then the next item in the list would be throughway/n port. Then it would be Jason, comma, and then it would be Ohio, like the OH, and then it would be another space, and then you'd have the zip code. Now, because the state is always going to be the penultimate item in that list, we can just take that item out. So remember, with list indexing, -1 will get you the end of the list, -2 will get you one from the end of the list. So we're going to use -2 and return that kind of second last element in the list, which will be the state. And then we're just going to return that there. So just to check this works, we're going to take the first address in our data frame. So we're going to get the address column, get that first element in there, and we're going to put it through this function. And we get out MI for Michigan, and we can see in the first row, the state is indeed Michigan. We could also try it with the second row, and we can get CA, California, and that's also what we'd expect. So we've just done a little bit of testing, made sure, OK, our function works. Now, it would be very arduous to go and just do this manually for every row that we've got in our data frame. We've got 462 entries. That's a lot of processing. And this is where the apply function is really quite powerful. So what we're going to say is we're going to say, OK, we're going to replace the e-commerce data address. We're going to kind of overwrite it with this value here. So what this is saying is we're going to take e-commerce data. We're going to take the address column, so get that big, long column of addresses. And now we're going to apply our function here, address process, which we defined up here. So that's going to take each item in the address column, each address is going to put it through that function, and then it's going to spit it back out and kind of overwrite the column itself because we've told it to here, we've specified the same column. If you change this to like address process, it would generate a new column in the data frame, and it would then keep the original address and the address process. But again, because we're pretty happy that we don't need the full address, we just want the state code, that's perfectly fine. So we'll go ahead and run this and also print out the head of the data frame. And you can see now that for each address, we've replaced it with just that simple state code. And this might allow us to explore more trends, especially a lot more than we would have been able to with like those massive, long, very specific addresses we had before. So now we can actually go on to kind of explore some of these trends. We've processed our data a bit. We've got an idea of how it works, how it looks. So let's see if we can kind of analyze it a bit more. Now, there's a library in Python called matplotlib. And this is designed to emulate MATLAB, if you've heard of that. Kind of a mathematical programming language, very good for generating graphs of data and stuff like that. I wouldn't worry too much about that, but one thing that's really good with matplotlib is it has a lot of functionality, way more than we could cover in this simple session here. So I've put a link in this notebook here. It will give you, I'll just actually open it just so you can see. It'll tell you a lot about the different plot types. So we can do line plots, scatter plots, bar charts, stems, stack plots, stair plots, various statistical distributions, various like kind of grid plots. So you can see there's a whole load, like even 3D plots. It can do pretty much any type of graph you want. Matplotlib can probably do it. Really, really powerful stuff, but obviously potentially quite complicated. So I'd recommend trying to understand the stuff we got in this notebook first, but then definitely do feel free to like explore some of those plots. I found it personally like really helpful to have an understanding at least of what's out there, just so if I get to a problem, I'm like, oh no, I might need a 3D graph or something like that. I know where to look. I know to go, okay, I'll go to this website, see what matplotlib says, read some documentation. Hopefully it'll tell me what I need to do. So what we're going to do is going to import the library. Now, the way I'm going to do this, I'm going to import matplotlib.pyplot. So pyplot is kind of the module that allows it to do Python plotting. And we're going to use this, because this is quite a long thing to type in each time, I'm going to use this as keyword just to tell Python, whenever I refer to PLT, I want you to kind of think of this. So this kind of allows us to use PLT as a substitute word for this big, long kind of definition of the library here. It just makes our stuff a little bit nicer. The other thing I've done is this matplotlib inline method just tells Python how we want to display the plots. Because we're in a notebook style, inline kind of tells it kind of effectively display them in line with the output. So a graph will appear as kind of output to our cells, which is kind of what we want. We don't want it to be like some random other place in the notebook or not display at all for whatever reason. So if you're working with Jupyter Notebooks, I'd recommend if you're going to do some graphing, these two lines are kind of the first thing you just want to put in, because that'll allow you to, it imports the library and it makes the styling of the plots look nice. The other thing I'm going to do is I'm just going to tell it to use the dark background style. This is because my notebook is on dark mode. It makes the plots look a bit nicer. I could show you what it looks like without that, and then you can kind of see the difference. So yeah. So in this instance, what we're going to do is we're going to generate a scatter plot. So once we've done all that kind of importing the library, telling it what style to use, whatever, now we can actually start plotting the data. And this is really quite simple. We're just going to tell PLT, so telling the library we want to generate a scatter plot. We're going to pass it in the X data, which is going to be, we're just going to do the average session length. Let's see what that looks like, and the yearly amount spent. So the yearly amount spent is kind of that value we want to understand. We want to see how does the average session length affect the yearly amount spent. So we're going to call plt.show. And because I've turned off the dark background, you can see it looks like that. It's fine for the data points. It makes the axes a little bit harder to see. So I'm just going to turn that back on. But just to give you an idea of what that's doing. So we can see here that there's some correlation between the two. There's kind of, you can almost see like a very, very subtle kind of line going through here. But overall, it's kind of a rough like blob sort of shape. So not a massive amount of correlation between those two categories, but still useful information to see. So what we're going to do now is we're going to try something a little bit more complicated. We're going to try and graph, if we go back to our data just here, you can see that we've got 4 different numerical columns here. So we've got the average session length, the time on the app, the time on the website, and the length of the membership. And all of them, we want to understand how do these affect the yearly amount spent. So what we're going to do is we're going to create a plot where we can see all 4 of them at once. And this kind of allows us to see kind of how matplotlib works behind the scenes. I've written quite a long kind of description here of how this all works. I'll go through it. I won't kind of read through this word for word. I'm probably just going to explain the code here. But I would recommend afterwards, if this bit's a little bit confusing, going back to that description, playing around a bit and seeing what happens. So what we're going to do is we're going to define a couple of things here. We're going to define a figure and some axes. So the figure is kind of our overall space that we're going to draw the graphs in, and then the axes are going to give us kind of an x and y axes for each graph that we're going to draw. So we're generating this from the plt.subplots function. So this tells it we want to generate 4 subplots, and we're going to generate them in a grid shape with kind of 2 columns and 2 rows. So you can kind of imagine how that looks. You've got 1 column, 2 column, 3 column, 4 column, 1 column, 2 column, 1 row, 2 row. So you're going to get 2 plots there, 2 plots there. So 4 plots in total. So it's a little bit confusing, but you can kind of see how that works. Effectively, if you multiply the 2 numbers together, you get the total number of graphs that you're going to be drawing. We're also going to set the figure height and the figure width. This is just for kind of display purposes, so it's not displaying them too small. And I'd recommend like playing around with this. You could change one of them to 20 and one of them to 10. Be a wider figure instead of, or in that case, would be a higher figure instead of this one. At the moment, we'll keep it as 10 and 10 because that's going to generate a nice squared shape. And then for each axis, we're going to kind of effectively set the plot. What I'll do, I'll make this a little bit more easy to read and just kind of separate each axis out with a space, with a new line, so you can kind of see what's going on. So similar to what we did before when we called plt.scatter, instead of calling plt, we're going to use the axes objects that we've created. So we're going to call axis. This is going to be kind of our grid, effectively defining where these axes are. And then we're going to pass it 0, 0. And this is telling it we want to go for the 0th row and the 0th column, so top left. So in the top left, we want a scatter plot, and we want it to do average session length and the yearly amount spent. And then we're going to just set a title that tells us what it is, the average session length. And that's just done with the set title function, so fairly self-explanatory. Then we're going to go on one, so we're going to go for the 0th row and the first column. So kind of, if you imagine we've done top left, now we're doing top right. And this one is going to be the time on app, and then the yearly amount spent. Then we're going to down to the bottom left and do the time on the website and the yearly amount spent. And then we're going to go to the bottom right and do the length of the membership and the yearly amount spent. So I can appreciate that code's quite long, but you can see that like there's a little bit of repetition in what's going on there. We're effectively just going one by one and telling matplotlib, we want to plot this graph here, that graph there, this graph down here, and that graph down there. And at the very end, we're going to say plt.show just to make sure that the plot's displayed. That kind of tells matplotlib, I've done defining all my graphs, I've done defining all my plots, I want you to display them. Go ahead and run that. It'll take a little bit of time. And you can see that we get some really quite interesting plots of the data. So we can see here that the time on website seems to have like very little correlation, it's just a big blob. The average session length a bit more, time on app a bit more so, and then the length of membership seems actually quite strongly correlated with the yearly amount spent. We've got quite a strong kind of line starting to form there. So already we're developing some intuition about our data, we're understanding how does it work, what's related to what, kind of thinking that business mindset again, how could we generate profit, how could we exploit this? So yeah, and then there's another kind of description here of kind of how that correlation looks. Now the other thing we want to have a look at, as I mentioned earlier, is we've converted all of our addresses to states. So why don't we have a look and see if we can do a graph of how much what's the yearly amount spent for each state? And it might give some information. Maybe there's one state that's just spending like loads and loads on our site, and there's another state that's not spending very much. And this is, again, we're going to use a different sort of graph. We're going to use a bar graph for this. So similar to last time, we're going to define a figure, and we're going to give it this argument here. We're going to say figure, the 1 is going to define we just want one plot, kind of one graph, and then this argument here is defining the size. Because there's a lot of states, we're going to make this one quite wide. So we have space for kind of all of them to fit on, so we're going to give it a width of 20 and just a height of 5. It doesn't need to be that tall. Then we're just going to add our axis, and this kind of add subplot command here is telling Python we want one row, one column, and then that kind of first index. So in the case before, we had 2 rows and 2 columns. So this function, when you use it, you probably put 2, 2, so it knows the number of rows and columns, and then this index here is going to say, do I want graph 1, 2, 3, or 4 within those 2 rows and 2 columns? So it's a different way of kind of telling matplotlib, telling Python which graph you're targeting. In this case, it's a little bit trivial. We've only got one graph, so we're only going to have one row, one column, and one index. So we just tell it 1, 1, 1, and it will find that graph for us. But in more complicated examples where you might be adding axes kind of in a for loop or something, this is really helpful because you can replace the 1 at the end with an I, and then as you iterate through the for loop, it's just going to continually update that index and change which graph it's looking at, so you can plot like loads of different graphs. And then we're going to actually define our plot. We're going to call ax.bar, very similar to how we did like this function here, axis.scatter. But in this case, we've only got one axis, so it's just ax.bar. We don't need that indexing because we've only got the one axis. And then we're going to put in the address and the yearly amount spent, very similar to how we did that scatter plot. The last thing here is kind of a bit of a quality of life feature. The plt.setp method is going to allow us to kind of affect what the font of the graph looks like. So in this case, we're specifically targeting the labels on the x-axis. When I plotted this originally, I found that they tend to overlap. I can kind of demonstrate, actually. So if we go ahead and run this as it is, you can see we're going to get out the graph. Fingers crossed. There we go. It takes a little bit of time. But you can see along the bottom, some of these labels are a little bit, they're starting to overlap slightly. They don't look very nice. What this function here is allowing us to do is just make it look a little bit nicer. So we're telling it to get the labels on the x-axis, the x-tick labels, and we're just setting the font size to 8 and the rotation to 30. Obviously, it's a little bit small, but you can see that that looks, as a graph, a little bit nicer. The states are kind of more separated from each other as labels. We're not getting any sort of nasty overlapping. Now, overall, we can see that in this graph, roughly, the yearly amount spent is fairly equivalent across all the states. You can see a couple, there's kind of a bit of a dip here, quite a high peak here. But overall, they're all kind of in the same ballpark. There's not one state that's like massively higher than the others, and not one state that's also massively lower than the others. So potentially not something that we really seek to investigate further, but potentially we have more time. We might spend a bit more time looking into that. So that kind of covers the basics of kind of data processing. I'm just going to quickly run through them again, just so you can kind of see what we've done before we try and do like this little bonus exercise at the end. So we imported our data. We kind of cleaned it up. We removed those null values using this drop nav function or drop na. We did some data processing. We removed the email and the avatar. We changed the address just to be the state. We did some data visualization. We plotted a couple of things as scatter plots, and we did the bar plot as well. And from these like scatter plots and the bar plots, especially the scatter ones, we're starting to understand, you know, what's our relationship with the data. Particularly, how do these various factors, the time on app, the time on website, etc., how are they going to affect the yearly amount spent? Now, one of the really cool applications of Python and programming in general is being able to make predictions, being able to do some sort of learning. So we're going to do kind of as a bonus, so don't worry if you don't really understand this too much, but it should hopefully show you how easy it is, now that you've got all these skills that you've learned, how easy it will be to start generating some really powerful functionality, start effectively doing machine learning. Now the technique we're going to use is linear regression. It's quite a common technique, quite like, in terms of the mathematics, it's quite old, but it's very, very powerful for tasks like this. So the first thing we're just going to do is we're going to take our data and we're going to separate it into features and values. So you can see our features, we're going to get the average session length, the time on app, the time on the website, and the length of the membership. So we're just getting those numerical features in our data. And for the values, we're just going to get that yearly amount spent. That's what we want to predict. That's what we want to understand. So we're going to go ahead and do that. And effectively what this will do is this is going to create kind of two smaller data frames, one with just the features and one with just the values. So I could almost do at the end here, features.head. And you'd be able to see it's just a smaller data frame. It's just kind of a subset of the big one we started with that just contains those features we're looking for. And similarly, values is just going to be a series. If we just print it out here, the values array, the values is just going to be a series, and that just basically means it's just like a big list. A series is similar to a list. It's a specific Panda data type, has a little bit more functionality, but effectively every data frame column is just a series. So that's why that's the value we're getting out there. And you can see that's just got all the values for the yearly amount spent for each row. So again, we're going to use another library for this. You can start to see that actually when you get onto this sort of level, libraries become a really, really powerful tool. So definitely try and get comfortable with using them. So we're going to use this library called scikit-learn, sklearn.linear model, and we're going to import the linear regression model because that's the technique we want to apply. we're just going to generate the model, kind of generate the object just by calling linear regression, and then we're going to fit it, lm.fit, to our features and our values. And this is basically training our model. This is what this function is going to pass in all the different features, all the different like the values of the time on app, the time on website, the session length, stuff like that. And it's going to try and learn to predict the yearly amount spent based on those values it's getting in. Just go ahead and run that. You can see it takes a little bit of time. Machine learning isn't a quick process, unfortunately. But there we go. And it kind of gives us this output. It's not really that helpful. It just tells us that there's a linear regression model that we've created and that now it's been trained. So what we're going to do now is we're going to generate some predictions. And that's basically just to do this in Python, it's very, very simple with this sort of model. We're just going to do lm.predict and then features. So we're just going to want to see how the model's performed. So we're going to pass it back in the features, and we're just going to see how it predicts the values. And the way we're going to see that is we're going to do a scatter plot of the values, the true values on the x-axis and our predictions on the y-axis. So what we'd imagine, if the model is really terrible, then there shouldn't be much correlation between those two values. The scatter plot should look kind of random. But if there's a lot of if the model's quite good, then you should be almost a straight line. Because effectively, as the points get closer together, that's our model getting closer to the true values. So we can go ahead, we can run this, and we can see that the output is roughly a straight line. Obviously, there's a little bit of deviation here and there, but largely, that's a straight line. The interesting thing to note, if we go back to the graphs we drew earlier, is that combination is a lot better, a lot more correlated than any of these we could have used to predict beforehand. So what we've done is we've effectively used Python libraries, we've used techniques that are quite complicated, but don't require that much code to generate, to take kind of this data and make it a lot more valuable. Because now we're able to generate predictions that are a lot more accurate, a lot more correlated to the actual kind of the actual data. So yeah, in an actual data project, you probably spend a bit more time looking into train and test sets. I won't really go into all the machine learning side of things because that's not really the point. But the last interesting thing we can just have a look at is the coefficients of the model. So we're going to kind of put this into a data frame, but effectively we're getting this linear model here, .coefficient underscore, and this will grab the coefficients. These are the values that the model has learned. And this can just help us understand the data a little bit more. Go ahead and run that, and you can see these are the different coefficients. And what these tell us is for a 1 unit increase in any of these quantities, this is the increase we can expect in the yearly amount spent. So if the average session length increases by 1, then we expect 25 increase in the yearly amount spent. What's really interesting, we can see how these different quantities affect the yearly amount spent. So for example, the length of membership seems to have a really, really strong effect. Like that's increasing, every unit length of membership increases our yearly amount spent by 60. Whereas the time on the website only increases it by, time on the website only increases it by 0.4. So there's a really big difference there. But again, this is something that we could have seen in our data beforehand. It's kind of confirming what we saw beforehand. The time on the website, kind of a bit of a blob, very, very random. Length of membership, a lot more correlated with the yearly amount spent. So again, we're kind of reassessing, we're reevaluating, we're understanding our data more, and it lines up with everything we've seen before. So we're really quite confident that the things that we've drawn out, the understanding we've got is accurate. It's not just kind of fake or random. So yeah, so overall we can see that in a short session we've gone through processing data, we've gone through visualizing data, we've gone through cleaning data, and we've also gone through a tiny little bit of machine learning. We've been able to generate some predictions from the data. All of this very, very powerful, very, very valuable. So I hope you've enjoyed this session. There's some exercises as per usual in the notebook, and the notebook's available on the Google Drive. The exercises might be a bit more complicated. It is the last week of the course. So yeah, hopefully if you do get stuck, then we'll be able to come and help you, but hopefully you shouldn't find it too difficult. I'd really recommend going over the notebook itself if you need any hints and tips. But yeah, they'll kind of take you through the first exercise will kind of take you through just using the data frame, kind of understanding that indexing. The second one's going to take you through some processing side of things. And the third one's going to do a simple graph visualization. And a lot of them they're all going to be using the data set that we've just been exploring. So hopefully now that you're kind of familiar with this e-commerce data set, it'll be a bit easier to kind of take on these exercises. But yeah, so I hope you've enjoyed this week. I hope you've enjoyed the Python course as a whole. I'm sure myself and everyone else has really enjoyed kind of presenting it, generating the material for it. And yeah, we hope you get a lot of value out of it. So yeah, go ahead, do the exercises, let us know if you get stuck. But yeah, enjoy, go and apply your Python skills to the world.